So I want to take a few minutes and talk through data formats for appointment scheduling, particularly around COVID-19 vaccination appointment slots. And I'll be sharing a few examples that are currently hosted in the Smart Scheduling Links GitHub org. In smart-on-FHIR.org, Smart Scheduling Links is the repo. And what I want to show you is a quick example of what it looks like to convert from an ad hoc JSON format into a standardized FHIR-based JSON format, and take you through the exercise of what it looks like to do that conversion. So first, a quick tour through the input data format, which is one that was defined specifically around this use case of COVID-19 appointment slot discovery. And it's an array of locations, and each location provides details about where the place is physically found, how to get in touch, and then day-by-day availability in terms of total slots for vaccinations and available slots. And it's worth saying there's some information here that's implicit. So, for example, the fact that these are COVID-19 availability slots is really implicit in this API. And that's one example of something that using a standards-based format can help with, which is to make explicit, which makes it easier to use these kinds of data in different use cases or to plug different systems together. So I want to take you on a quick tour of a script that uses this kind of format as an input and then produces as its output a set of FHIR JSON resources, which are just a different standardized JSON schema that represent a physical location, a schedule at that location, and then individual slots for the schedule at that location. And together, these three kinds of resources, locations, schedules, and slots, tell the story of COVID-19 appointment availability, but they tell it in a way that allows us to get quite fine-grained, so that rather than just doing scheduling slots day by day, we can eventually have a path to doing specific appointment slots and guiding a user through that whole booking process. So that's one of the advantages, again, of using a standardized model. So I want to take you on a quick tour of a conversion script that goes from the input that I showed you to the output that I showed you. And I'll just give you a quick sense of the steps that are involved. It's really just about 100 lines of TypeScript code or JavaScript code to do this conversion. And the main function here is one that inputs a location, so that top-level object from the input document that we looked at, and it creates the three kinds of FHIR resources that we need for the standardized representation. So the first thing to do is the actual physical street address, which is a very straightforward mapping of input fields like location.street and location.city into FHIR fields, which have very similar names. So a very straightforward mapping. Couple field names are different. There's an array of lines instead of line 1 and line 2 as explicit separate properties, but a very straightforward mapping. And then once you have this address, you can slot it into this location object, which represents not just where to find the place, but also what it's called, the phone number and URL for getting in touch with that location, and a list of identifiers. And so an example of an identifier for this location would be a VTRAX ID or a VTRAX provider PIN. And so that was represented in the input documentation as the top-level ID item. And in FHIR, we think about that as an identifier specifically in the VTRAX URL scheme. So if you have this PIN number, you know specifically that it's a VTRAX PIN based on the way this system is populated. So that gives us a location. There's one detail I glossed over, which was how to assign a stable ID to this location. In most real-world systems, you would just already have an ID for this location and you would use it here. But since we didn't, in this case, I wanted a unique ID, and I just took a hash of the physical street address because I figured that would be something that would be stable over time. But that's just an implementation detail of this script. Once we've created a location resource, now we can move on to create a COVID-19 schedule or COVID-19 immunization schedule for that location. And this basically is just a schedule resource that says what sorts of services are available here. And it does that using standardized concept, codable concept, one that tells us this is an immunization service, and then one more detailed code that tells us this is specifically for COVID-19 immunizations. And together, this sort of tells the story of what kind of schedule this is. It's the COVID-19 schedule. And then it includes a link to the location. So we know this is a schedule for this service being offered at this specific location. And this is really important as we start to think about use cases where other kinds of schedules might be made available at the same location. So we've made a location, we've made a schedule, and the last thing we need to do is represent appointment slots. And in the ideal case, appointment slots would represent specific narrow windows of time where an individual patient could book an appointment. But to get started, it's easy enough just to take each day of availability from the input document, and for each one, just create 2 slots, one representing free or open capacity, and one representing booked or busy capacity. And so what we do here is for each of those days, we create a day-long slot, just saying, this starts whenever the clinic opens for the day, and it ends whenever the clinic closes for the day. And we've got one slot representing free capacity, where we'll say however many available slots there were, that's the free capacity. And then we've got our second slot that represents busy capacity. And here I have to do a little bit of subtraction because the input document doesn't tell us how many busy slots there are. It just tells you total slots and available slots. But if you subtract those things, then you get the number of busy slots. So now we've got 2 slot resources, one representing free capacity, one representing busy capacity. And on the free capacity slot, we also include links for next steps that a user can take to book that slot, either a web link for booking online or a phone number for booking over the telephone. And that's it. Basically on this conversion, we've now created a location, we've created a schedule, and we've created a list of slots. In this case, 2 slots for each day of availability that we know about. And the rest of this file just runs this conversion on each of the locations in the example. And then it outputs a markdown formatted document, which is what we are looking at here, just so you can see at a glance exactly what the outputs look like in a single file. So that's a quick tour. I hope that makes sense in terms of the actual conversion mechanics themselves. They're pretty straightforward. All the information from the source document has a home or a place to live in the standardized output, and it doesn't require any great feats to map those data. One question you might have is, okay, if it's a purely mechanical operation, what's the point? Why bother even doing this? Why not just expose this kind of idiomatic data structure at the source? And the answer here really has to do with the extensibility path over time. Use cases evolve. Even a simple use case like COVID-19 scheduling will evolve to go from is there a slot today, to how many slots today, to what time are the slots, to can I take a user through the whole booking process. And if we start with this sort of idiomatic JSON structure, we're going to have to keep evolving it and creating new capabilities to this structure over time. Whereas if we start with the standardized structures like the JSON FHIR that we're looking at here, it gives us a broad community consensus to build on, and it gives us a set of data models that work not just for this use case, but for the next set of use cases that we'll grow into over time, and gives us a way to plug into other health record systems and other healthcare data systems that are working in the same environment. It's really part of a broad national investment in health data standards that we've been making over the last decade. So I hope that gives you a little bit of an indication about how we can do this mapping and why it's important.